My name is Kenny Heidel. I'm the Product Marketing Manager for Components, and today I'm going to talk about the K6CM. We're going to go over the three different types of K6CM, show how they physically connect. We're going to show the HMI screens that we have developed. So as you see here on our demo, we have our S8VK-S power supply, our W4S industrial switching hub, and then the three different types of K6CM. We have the K6CM ISM for insulation resistance monitoring. We have the K6CM VBM for vibration and temperature monitoring. And we have the K6CM CIM for current analysis monitoring. With each K6CM, there is an associated sensor with that version. For the K6CM ISM, we have a zero-phase current transformer that is clamp type. For the K6CM VBM, we have a vibration and temperature monitor. And for the K6CM CIM, we have a clamp type current transformer. As you see here on the local display, we're showing green on each one. This local display will show green, yellow, or red, depending on if the thresholds are hit. Up at the top here, you can see these LEDs are connected to each of the transistor outputs. These transistor outputs are fail-safe, so in the event that you have hit a warning or critical threshold, the LED will turn off. As you see here, I will simulate. The LEDs have turned off, and you now have a red warning on the local display. This can be reset by just pushing the alarm reset. Now I will go into more detail on the local display of the K6CM as well as the HMI screens that we have developed. Here we are showing the local displays for each K6CM. You can see the variables that each K6CM sensor is monitoring locally on the display. For the insulation resistance, you see mega ohms and milliamps. For vibration and temperature, you see G's of acceleration, velocity, temperature, and then delta temperature between the motor and the ambient. Right here is our vibration amplifier, which is also measuring the ambient temperature to compare to in the delta T. And lastly, the current analysis will show the current as well as the degradation level, the deviation from a uniform sine wave that will result in some kind of warning or critical threshold. Moving on from the local displays, everything that you can display locally on the K6CM, you can show on an HMI. In an effort to speed up commissioning time of the K6CM, we have developed sample software for the SysMac platform, as well as sample HMI screens for the NA-HMI. As an example, I will show you the HMI screen for the K6CM current analysis model. Here we're showing the actual value of the current, as well as the minimum and maximum that the current has been recorded by the unit. Here we are showing the degradation level current value, as well as the maximum and minimum recorded degradation level. You can reset them using this button in the middle. Below that are the current states of the alarms for both current and degradation level. And on the bottom, we are showing the physical status of the three transistor outputs: warning, critical, and self-diagnoses. Now we will go into how to connect the sensors to the motor. Here we are showing a sample wiring diagram for the K6CM VB model. On the upper left, you have the connection to actually trigger an output of the vibration sensor. On the upper right, you have the connection of the K6CM VBS, the sensor head, and the preamplifier that we showed in the demo. On the bottom right, you have the three sets of transistor outputs that are open collector transistor outputs. And on the bottom left, you have the Ethernet IP connection to either a PLC or computer. Here we are showing the wiring diagram of the K6CM IS version. Just note, If you are not using an inverter, the wiring is the same, just without the inverter shown there. And the manual also has other types of wiring for the insulation resistance version. And here we are showing a sample wiring diagram of the K6CM current analysis version with the dedicated CT that is clamped across one phase.